Hey everyone, if you want to write cleaner, smarter, and way more efficient Java code, you have got to master inheritance. Seriously, it's a huge part of object-oriented programming. So today, we're going to break down two of the most common types you'll see, single and multi-level inheritance. Let's jump right in.
So here's the game plan. First, we'll get a solid grip on the big idea of inheritance itself. Then we'll see how it works with a basic single-level example. After that, I'll throw a little coding challenge your way that shows its limits, and then we'll solve it by leveling up to multi-level inheritance. And of course, we'll wrap it all up with a quick recap to make sure everything sticks.
All right, first things first. Before we dive into the different types of inheritance, let's get on the same page about the fundamental concept. What are we even talking about when we say one class inherits from another? At its heart, inheritance is all about reusing code you've already written. It's a way for a new class to kind of absorb the features and behaviors of a class that already exists. This creates what we call an is-a relationship. Think about it. A dog is an animal, right? So it makes total sense for the dog class to inherit things like eat or sleep from the animal class. Or a car is a vehicle. This logical connection, that's the key.
You know, the absolute best analogy for this is a family tree. It just clicks. A son inherits traits from his father, who in turn inherited traits from his father, the grandfather. It's exactly the same in Java. One class can get its methods and variables from a parent class, which might have gotten them from a grandparent class. It's this beautiful downward flow of features.
Okay, so keeping that family tree idea in our heads, let's look at the simplest version of this, single-level inheritance. This is the foundation for pretty much everything else, so it's super important to get this down.
The structure couldn't be simpler. You have one parent class, which we also call a superclass, and one child class or subclass that gets its stuff from the parent. That's it. It's a direct one-to-one link. Class B is borrowing from Class A. Done.
So let's make this concrete with a real example. Imagine we've coded a basic calculator class. It's simple. It can just add and subtract. But now we need an adv calculator, an advanced calculator, that can also multiply and divide. Well, instead of just copying and pasting the add and sub methods, which is a huge no-no, we can just have our adv calculator inherit them from the original calculator.
So how do we actually do this? How do we make this connection in the code? Well, it all comes down to one little magic keyword, extends. When you type class advanced calculator extends calculator, you are literally telling Java, hey, this advanced calculator is just a more specialized version of calculator. Please give it all the public stuff that calculator already has. It's that easy. Okay, so single-level inheritance. It's clean, it's straightforward, and it worked perfectly for our advanced calculator. But let's be real. In the real world, things are never that simple. Requirements change, features get added. So what happens when our calculator needs to get even smarter?
Let's throw a wrench in the works. Imagine your boss comes to you and says, that advanced calculator is great, but now we need a scientific calculator. This new psi calculator needs to have a power function, for exponents. But it also has to do everything the add calculator can do. How on earth do we build this without rewriting a bunch of code?
And the answer to that problem is our second topic for today, multi-level inheritance. This is the tool we pull out when we need to build a whole chain of classes, where each new class in the chain adds its own special layer of functionality.
So here's how our chain gets built. We start with our original base calculator class, that's the grandfather. Then the advanced calculator extends it, becoming the father. And finally, our brand new psi calculator extends advanced calculator, making it the son. See that? Each level inherits directly from the one right above it. It's a lineage.
And the code to do this is just so clean and logical. You can see it right there. Add calculator extends calculator, and then psi calculator extends add calculator. This structure isn't just easy to read, it's also amazing for maintenance. Think about it. If there's a bug in the add method, we only have to fix it in one place, the original calculator class. And that fix automatically trickles down the entire chain.
Now this is where you really see the power of the chain. Just look at what each object can do. An object of the calculator class, it can only add and subtract. An add calculator object, it gets those methods plus multiply and divide. But the psi calculator, at the very bottom of the chain, it gets access to everything, all the methods from all of its ancestors. It's this cumulative, cascading flow of functionality.
All right, we've seen them both in action. Let's take a second to really nail down the key differences. This is the kind of stuff that's super important to have crystal clear in your head, especially for a test or a technical interview.
The bottom line is all about the structure.
Single level is just a direct parent-to-child relationship. Class B inherits from Class A. That's it. Multi-level, on the other hand, is a lineage. It's a chain. C inherits from B, which inherits from A. Just think, a simple pair versus a whole family line.
So let's wrap this up. If you forget everything else, remember this. The whole point of inheritance is to reuse code logically. Single level is your basic one-parent, one-child link. Multi-level is when you build a chain of those links. In both situations, that extends keyword is your best friend, and all the cool features and methods always flow downwards, from parent to child.
And that leaves us with one final, very interesting question to think about. We've built this chain where every class has just one direct parent. But what if we wanted a class to inherit features from two totally different, unrelated parent classes at the same time? Is that even possible in Java? Now that is a critical question, and the answer tells you a lot about how Java is designed. But it's a topic for another time. Thanks for joining me.